Hi everyone, welcome to your first Play Pause It lesson. We are going to be covering these units from your OMHS course, so go ahead and grab your notes and let's get ready. Today we're going to be able to work through these items here. We're going to simplify expressions, recall using PEMDAS, determining if two expressions are equal or not, and then translating. This meme makes me laugh. Oh, so much. Thankfully, you guys will never have this happen to you because we will be using the Desmos calculator in class all year long. The Desmos calculator is a web-based calculator, so all you'll need is a link, and you can access it from any web device. You can even access it from your phone. Okay, so first I wanted to see if any of you have ever changed a tire. Now, maybe you haven't done it yourself, but maybe you've seen someone do it or you might be able to determine the steps. So I wanted to look at these pictures. These pictures are out of order and we're going to put them in the proper order. So here we're going to definitely put our caution sign down first when we pulled over to the side of the road. And then number 2 is going to be to jack up the car. We got to be able to access that tire, right? Then we're going to loosen those lug nuts on that tire. Unscrew them would be the next step. And then it looks like there might be a step missing from these, but we're going to have to remove the old tire, right? And then step 5 over here is going to be to put on the new tire. And then go ahead to tighten those bolts back up. So you can see there's definitely a proper sequence of steps to change a tire. I mean, I don't think we could do it any other way. Like there's no way we could take the tire off before jacking up the vehicle, right? So similarly, we have an order in which we simplify and solve expressions. It's a proper order, and we call it PEMDAS. So we're going to get to that, but before we do, I wanted to just do a quick exponent review with you guys. So remember, this little number here at the top, that is called the exponent. And all that number means is for you to write this base number here that many times. We're going to multiply it by itself however many times the exponent says. So in this case, we're going to do 2 times 2 times 2. And we'll solve this. 2 times 2 is 4, and then 4 times 2 is 8. So 2 cubed is 8. Let's try another one. What if we had 3 squared? So all this means is to write this base number 2 times because the exponent is twice. 3 times 3 is 9. A common mistake is sometimes people will do 3 times 2. But just remember that this is how many times they want you to write that base number. 2 times. So what if we tried 4 cubed? That would be 4 times 4 times 4. Certainly, you guys have your calculators. You can use them throughout this entire class. There's no restriction on your calculator use. I do want to say that I feel like we should use our calculators as a tool to support us, right? You don't want to use them necessarily to replace your thinking because sometimes even calculators can make mistakes in a sense, right? Because they're only as smart as the people using them. So let me show you how we can use our calculator to do 4 cubed. I'm going to go here to the the Desmos calculator. The one we're going to use in class is the graphing calculator. This is what it looks like. And here at the bottom left-hand side, you'll see a little keyboard that we're going to pop up. This is our scientific keyboard. So all you have to do is click 4. You can use your keyboard or you can use your mouse to select the 4. And then over here are your exponent buttons. So we have the one with the little 2. So that's going to square a number for us. And we also have one here with a b. The b is going to let you put in any number you want. That b is like a variable. So we're going to do cubed. I'm going to click the b and put 3. And you can see how it put the little 3 up in the exponent value. And then it'll automatically tell you 4 cubed is 64. So let's go ahead and go back. So sometimes it's just a good way to confirm your work. All right, let's do a quick fraction review. So to multiply fractions, all you guys have to do is multiply straight across. So 1 times 2 is 2, and 2 times 3 is 6. And then if you can, you should always simplify. Think if there are any values that will go into each of these evenly. Do they share a common factor? And here, it's always a good idea to try 2. So we can divide each of these by 2 and reduce this fraction. 2 divided by 2 is 1, and 6 divided by 2 is 3. Now we are in simplest form. So with multiplication, all you do is you just multiply straight across. You could definitely, if you wanted to, you could simplify this before multiplying. So let's try that over here. You don't have to, but as the numbers get bigger, sometimes it's helpful. So if you see any common factors in the numerators and the denominators, you can reduce them. So I see a 2 here, a 2 here. So 2 goes into 2 one time, and 2 goes into 2 one time. So that's why we were able to reduce that. And then just multiply straight across. 1 times 1 and 1 times 3. And you can see we get the same answer. Let's try addition and subtraction. So what if we did 1/2 plus 4/2? So when we're doing addition and subtraction, the most important thing is you want the denominators to match. They have to have a common denominator. The number in the bottom is the denominator. So these are both 2, so we're good to go. All you do now is you add the numerators. 1 plus 4 is 5. And then bring our denominator over of 2. But what if the denominators are different? 1/3 minus 2/7. So in this case, we have to find a common denominator. And the easiest way to do that is to take the first fraction denominator and multiply it by the second. So multiply by the 7. That's what's over here. And whatever you do to the bottom of a fraction, you have to do it to the top. Keep it balanced. And if you think about it, look, 7 over 7 is just 1, right? So we're just multiplying this fraction by 1. So we're not changing the value of the fraction, we're just changing the way it looks. So 7 times 1 is 7, 7 times 3 is 21. So if you were to type 1/3 into a calculator, you would get the same exact decimal as 7/21. It's just changing the way it looks. So now we need the second fraction to match. We need to have it have the common denominator of 21. So we're going to multiply this side by 3. 2 times 3 is 6, and 7 times 3 is 21. Now that we have our common denominator, we can go ahead and handle the numerators. So 7 minus 6 is 1 over the denominator. All right, let's try another one over here. 1/4 plus 2/3. So we're going to make our common denominator. I'll multiply this fraction by the other one, by the 3. So we'll get 3 over 12. And this side by the 4. Get 8 over 12. Now that the denominators match, we can go ahead and just add the numerators. 3 plus 8 is 11. And you're done. I just want to show you guys how to do this on your Desmos calculator. So let's go to that real quick. So we can do, let's just practice. I'm just going to make some up. Might not be the ones we just did. 1/2. Now you can see I typed in a fraction, and my cursor is in the denominator right now. See it blinking? So you want to arrow over to get you off that line. Plus 2/3. Now it gives you this decimal value here, but more than likely, you're going to want to keep it as a fraction. If you're answering this as a question, make sure you're reading the instructions carefully to answer in the right form. But here, look over here on the left-hand side, there's a button we can push to turn this into a fraction. Kind of magical. So again, I don't want you guys to necessarily use this to replace your thinking, but it is a tool and it's there, and I want to show you how to properly use it. So let's try another one. Let's try subtraction. I'm just making up numbers. All right, let's turn that into a fraction, 27 over 7, and it leaves it as an improper fraction. So if for some reason the instructions say to write it as a mixed number, then you're going to have to do that, right? So the calculator can be a very powerful tool if used properly, right? So let's get started. Let's review PEMDAS. So remember, these letters stand for things. We have P stands for parentheses. E stands for exponents. Of course, I put two E's in there. Sorry about that. M stands for multiplication. D is division. A is addition. And you guys know S is subtraction. Now, sometimes you might have teachers use the acronym GEMDAS. And this G stands for grouping symbol. I'm going to put that here with parentheses. Grouping symbol. And that just means that you can have basically more than one set of grouping symbols in a problem. So this problem has a set of parentheses, right? But you might see problems that also have brackets, which is another type of grouping symbol. So that's why some teachers have kind of gone to this GEMDAS term, because there's not always going to be parentheses. You might also see brackets as grouping symbols. But anytime you have those grouping symbols, we're going to work our way from the inside out. So over here, we're going to start with 3 minus 4. So I'll bring down the other values. 3 minus 4 is -1. All right, now here I want to point out we have our exponent, and this exponent is touching the entire set of parentheses. So we need to make sure that to write that whole set of parentheses twice. -1 times -1. Now we're to the m, to our multiplication. So 2 times -1 is -2. I'm just going to bring these down. -2 times -1 is a +2. Now we can add and get 1. Now you can definitely take your Desmos to confirm this answer. It doesn't hurt just to double check. We might do that on a few in a minute. Let's try these. So we're going to use PEMDAS or GEMDAS, whichever you prefer. I don't see any parentheses, so let's do our exponent. 2 times 2 times 2. So 2 times 2 is 4, and 4 times 2 is 8. I'm just going to bring everything else down so you guys can see. So we did exponent. Now we're to the multiplication. I don't see any multiplication. So let's do D, division. We have a -4 divided by 2. That's going to be a -2. Now we have addition and subtraction. Something I want to point out to you guys is that multiplication and division, you can mostly do those in any order, working from left to right, and similarly with addition and subtraction. So we could go ahead and subtract these first and get 0, and we'll have 8. Or if you wanted to, you could do addition first. -2 plus 8 is a +4, and then you would have, I'm sorry, not 4, this is a 6. -2 plus 8 is 6, and you would have 8. So either way, you'll get that same answer. Now, I want to show you guys this one in the calculator because this is where sometimes the calculator could be wrong. Not so much wrong, but you got to be careful with how you put it into the calculator. So we have 2 minus 4 divided by 2. Now look what happens if I just kept typing. Plus 2 cubed. Like if I just kind of typed it as I saw it, this is what we would get. And that's not what we have, right? So be careful when you're entering the values into the calculator. See, my cursor is stuck there in the denominator by the 2. It's blinking. So I'm going to arrow over to get it up there to the regular line. Then we'll add 2 cubed. So be careful. Don't go too fast. Make sure you're entering it in the proper way as it's shown on the paper. All right, so sometimes you guys, I'll put these challenge questions here. If we're working on these problems in class and you happen to breeze through the first example, then you can try the challenge example. Let's try this one. We're just going to follow the steps. You can see that there's parentheses and brackets in this one. So we're just going to work our way from the inside out. So I'm going to start with the parentheses 3 minus 4. That's negative 1. And I'll just bring everything else down. We can do the same with the denominator. 12 minus 9 is 3. Let's go over here. Now working in those brackets, 4 times negative 1 is negative 4. I'm going to go ahead and multiply our 8 times 3, right? All right, now working in that numerator, we have negative 4 squared. Negative 4 times negative 4. I always run out of room. I write way too big. I need to work on that. Negative 4 times negative 4 is a positive 16 plus 2 over 24. Now we're doing multiplication, so negative 1 times 16, negative 16 plus 2 over 24. Negative 16 plus 2 is negative 14. And here you're pretty much done, but you should always see if you can reduce this. Remember we talked about earlier how you're looking for a common factor, the same number that could go into those evenly. And I usually start with 2. Try 2. If 2 doesn't work, try 3. Here, 2 works, right? 2 goes into negative 14, negative 7 times, and 2 goes into 24, 12 times. So here's the answer to our challenge question. All right, so let's try this guy here. This is a multiple choice question. It says, what is the value of x that makes the given equation true? So when you see an equation like this, we're actually going to learn how to solve equations like this, just straight up solve for x. But we're not quite there yet. So in this example, they gave us values. And we can take those values and plug them in and see if it's true or not. So let's try the first one. Let's try 16. So if we take 16 and plug it in everywhere we see an x, let's see if the equation is true or not. If it's true, that means whatever's on the left is going to equal whatever's on the right. I don't know about you, 16 is a pretty big number. We could definitely do this by hand. But again, at this level, you guys are totally allowed to use your calculators. So let's see, 4 times 16 is 64. And negative 12 times 16 is negative 192. All right, let's keep reducing using PEMDAS. 64 minus 3 is 61. And you can already see that these are not going to be equal, right? Because 192 is a huge negative number. But we can go ahead and get the value. It's negative 179. So these are definitely not equal. right? So it's not A. Let's try B. We're going to plug in a 0 everywhere we see an X and see if it works. See if the left-hand side does equal the right-hand side. And I'm guessing a lot of you can probably already tell, right? Because 4 times 0 is 0. So you end up with -3 over here and 13 over here. So no, these are not equal. So let's try C. This was A, this was B. Let's try C. We're going to take x equals 1. Let's put 1 in everywhere we see an x. All right, 4 times 1 is 4. 4 minus 3 is 1. Negative 12 times 1 is negative 12. Plus 13 is 1. We found it. 1 does equal 1. So that means x is the value that will make that true. The left-hand side equals the right-hand side. You don't necessarily have to do this, but I always think it's a good idea to try all the answer choices just because maybe you accidentally made a mistake down here in part C. So it's a good idea. Let's just double check and make sure D does not work because this one only has one answer, right? Otherwise it would say select all the true answers or all the possible answers. So let's just make sure that -3 doesn't work. To confirm we have the right answer. It doesn't take too long, especially if you're using your calculator. So 4 times -3 is -12. -12 minus 3 is -15. A little trick here, sometimes we like to use the trick KFC, keep change, keep the first value, flip the sign, and change the sign. So now you're adding two negative numbers. Pretty cool trick, it works every time. Over here on the right, 12 times -3 is a positive 36. So yeah, look, it definitely doesn't work. We get 49. So that's a good idea, just to always confirm. Our answer is C. All right, so let's look at this one. What is the value that makes the given equation true? So let's go ahead and try. It's up to you guys. Most people start with A, and they'll kind of work their way down. So we can do that if you want. Let's do 16 over 4. All we're going to do is take that x value again and plug it in everywhere we see an x. And then see which one is true. So 16 divided by 4 is 4. 16 squared is a huge number, right? Because that means to write 16 twice. 16 times 16. And that's 256. I guess it's not that big. Let's go ahead and do 71 minus 16, and you get 55. All right, 256 plus 4 is 260. You guys can already see these are not going to be equal, right? The left-hand side is way bigger than the right-hand side. You could certainly stop here. But it is going to be 257 equals 55, which it does not. So it's not A. Let's try B. I'm going to do it over here. So let's plug in an 8 everywhere we see an X. So 8 divided by 4 is 2. 8 squared, remember 8 times 8 is 64. Let's go ahead and do 71 minus 8. That gives you 63. All right, the left-hand side, 64 plus 2 is, ooh, this looks promising, 66. And then 66 minus 3 gives you that 63. Awesome job. So B is the correct answer. So for the interest of space here, I'm going to go ahead personally and not do these two. You should try them on your paper. I have done them, and neither of them do work. So it is confirmed the answer is B. All right, so let's work our practice with simplifying fractions. So we're going to use PEMDAS the same way, parentheses first. Here we're going to do 2/3 minus 1/3. So the great thing is that these denominators match. So we can go ahead and just subtract the numerators. So 2 minus 1 is 1, and we have it squared. So you can square fractions just like you square regular numbers, regular whole numbers. You just write it however many times the exponent exists. So 1/3 times 1/3. Remember, with multiplication, we're just going to multiply the top times the top and the bottom times the bottom. So we're going to end up with 1/9. All right, so PEMDAS says parentheses. We did parentheses, exponents, multiplication. Oh, look, there's some more multiplication here. So let's do that before we add. So it's up to you. I kind of think it's easier to make all the numbers look similar. So I'm going to make this a fraction by putting it over 1. You can always make a whole number look like a fraction by putting it over 1. Because 3 over 1, that's just 3. All right, we're going to multiply those. So 3 times 1 is 3, and 1 times 9 is 9. Okay, now let's add. So with adding and subtracting, remember we have to have common denominators. So I need to make these numbers match. So before I said that an easy way to do it is just to multiply each fraction by the other one, right? By the other denominator. But you don't always have to do that. Look, if we take this and multiply it by 3, doesn't that give us the 9 that we're looking for? So sometimes it's easier to do it that way. You're just trying to make the denominators match. So here we have 21/9 plus 3/9. You do not have to change both fractions. What you do have to do is if you multiply one by something, you have to do it to the top as well. So we end up with 24/9. And then just see if you can reduce this, right? So start with 2. Well, we know 2 does not go into 9. 2 is not a factor of 9. Oh, but 3 will work. So we can divide each of these by 3. So we get 8/3. All right, let's try this one in the calculator. So I can also show you guys how to be careful when you're entering fractions. So I'm just going to click this X here to make that go away. And we have 7/3. Now remember the arrow over to get you up to that line plus 3 times. Let's put in our fraction 2/3, arrow over, minus 1/3. Whoops. Arrow over, close up the parentheses, and then grab the squared. Okay, here's the decimal fraction, and we get our 8/3. There it is. It's a great way to confirm your answer, and just be careful how you enter it. All right, let's try this one over here. We're going to do parentheses first. Ooh, this one, the denominators do not match. And to be able to subtract them, they have to match. We have to, can we multiply one of them by to make them match? I think we should multiply this by 4. 4/4. So I'm going to bring down everything else. So you're going to end up with 1, I'm sorry, not 4. You guys get that? Should be 2. So it'll be 2/4 because 2 times 2 gives you 4. All right, now we can subtract. So I'm going to bring the other values down. So 3 minus 2 is 1/4. MDOT says we're going to do exponents next. So 1/4 times 1/4. You guys are probably on a roll by now, I imagine. 1/16. There we go. Now we're going to multiply these two fractions. Let's try something here. You don't have to do this, but sometimes if you notice that you can reduce a fraction prior to multiplying, it's a good idea. So as long as it's something in the numerator with something in the denominator, either place. So we know 4 goes into 4 one time, and 4 goes into 16 4 times. So I reduced that. So now you're going to have 5/4 plus 1/4. Because 1 times 1 is 1, and 1 times 4 is 4. Ooh, now we can add, this is so nice, the denominator is stacked already, so we can just add the numerators of 6/4. And you're, so again, you can definitely pause the recording at any time. Now might be a good time to pause it to try this challenge. The challenge is pretty cool. It has 3 grouping symbols in it. We have parentheses, brackets, and the curly brackets. I'm just going to show you how to do this. After you've already done it by hand, you can confirm your work over here. And be careful how you put it in. You could definitely find the brackets and the curly brackets on your keyboard, but I'm just going to use parentheses for everything. They're just another way to group things together. 1 plus 3, another parentheses, -6 minus 2, close, close, close. There we go. -57. So that'll confirm our answer for that. -57. All right. Let's try another one. And by now you may have just taken up your calculator, and that is okay. At this level, we're going to get to some more challenging topics. So let's do parentheses first. 3 minus 4 is -1. All right, and let's square that -1. Now the whole thing is being squared, remember, because these are parentheses. So -1 times -1. That gives us a +1, right? I'll bring down the -1/2. So -1/2 times 1, that's just -1/2. Anything times 1 is itself. Now let's find our common denominator. I'm going to multiply this side by 3, 3/3, and this side by 2/2. So that will give us -3/6 plus 4/6. So see, we did our job. We made the denominators match. Now you can add the numerators. You can add the top numbers. -3 plus 4 is 1/6. You could definitely use that calculator to confirm your work. All right, let's talk about the difference between an expression and an equation. And a lot of people find this really intuitive because the difference is in the name even. An equation has an equal sign. That's the main difference. So an equation has an equal sign. And an expression does not have an equal sign. That's it. That's the main difference. We're going to look at the parts of an expression next and the parts of an equation. I'm going to make one up for us here. What if we had 5x cubed minus 2x plus 4? All right, so the first thing to notice here is there are 3 terms. 1, 2, and 3. These are all terms. Terms are separated by addition and subtraction symbols. Terms, terms, terms. So we have 3 terms. So this 5 itself, that's not a term. I don't want you to think we have 1, 2, 3, 4, 5 terms. No, because these are stuck together by multiplication. So a term is separated by addition and subtraction symbols. All right, next, we've already talked about these, but these are the exponents, right? And next you have some x's in here. There's two of them. Those are called variables. Those values can change. That's why they're called the variable. This number here at the end has a special name. It's called the constant. So there's no variable with it, right? It will always be 4. That's it. It's not going to change. It's going to stay constant. The second term has an x with it. So depending on what the x value is, this term will change. So that's the difference here. This 4 has no x with it, so it is a constant. So we're going to use these words to talk about expressions and equations. Let's practice. How many terms does this have? I see 2 terms, right? Well, technically, let's see. Yep, this whole thing is 1 term, and this one is 1 term. Now you might see this subtraction here and think, oh, there should be 3 terms there, but remember our PEMDAS, and you would have to subtract these, making it just 1 number. So this is 1 term and this is 1 term. There's 2 terms. Here's our exponent. This equation doesn't have any variables, so they're all constant, right? All right, let's look at this example. This is my daughter, Sophia. So Miss Winslow pays a babysitter 1 to 2 hours per week to watch her youngest daughter, Sophia, while she attends some meetings. The sitter, who happens to be very qualified, charges a flat fee of $10 per month. That just helps cover her things like her CPR certification, maybe her gas money, maybe lunch money, and then $15 per hour. Can we come up with an equation to use for budget purposes? So when we're trying to come up with an equation, you want to think, what is staying the same? What's going to be that constant value? Because whatever it is, we're just going to tack it on to the end of the equation. So what is never changing? That's going to be that $10 per month, right? I mean, I guess unless the sitter decides to up it, but it doesn't have any variables with it. That's a flat fee. That's another clue word here, or clue terms here, flat fee. So we're going to add the 10 onto our equation. Now the value that is changing is the $15, and the clue words here are per hour. So that's going to depend how many hours she works. So you can use any variable you want. I'm just going to use x. Typically we use x, y, z, and t. Technically, you can use any letter, but you'll see as we get a little bit further on in algebra that there are some letters that we use for specific things. Like M is always slope. So it's a good idea not to use M for anything else. But technically you can. It's just we usually use X, Y, Z, and T. All right, so let's try these now. Now we have this workable, this is an expression. We can add an equal sign and make it an equation, and we can call it whatever you want to call it, total fee. So the second one here, how much do I owe her if she watches Sophia for 4 hours? So again, remember the hours is what changes. So we're going to take that 4 and plug it in for x into our equation and see what it is. So 15 times 4 is 60. 60 plus 10, that's going to be $70 that I'm going to owe that sitter. That's not too bad. The next one here, 8 hours, we're going to plug 8 in for the x and see how much I owe my sitter for October. So 15 times 8. It's 120, which just be double this, right? Plus 10 is 130. So I would owe her $130 for that month. Now I put this example in here because I actually used this. Last year when I was teaching, my older daughter was in school and I had a sitter come in a few hours per week and watch Sophia. And I was like, you guys, look, I made an equation. So I wanted to show you that it's an actual real world application that you can use when you're doing budget things, budget purposes. You can help your parents come up with some budget items there, you should do that. Pretty cool. All right, so let's try evaluating expressions with given variables. This is pretty similar to what we were just doing in the example that we created. So they'll give you an expression, and then they'll give you some values to use for the different variables. All you do is plug it in. So instead of y, I'm going to write 3. And instead of x, I'm going to write 1. That's it. And then you just simplify it using PEMDAS. So 3 plus 9 is 12. 12 minus 1 is 11. Let's try this one. See, here's y and z now. So y is 10, z is 2. So let's use PEMDAS, parentheses first, and then exponents. So we need to do this 2 squared first. Remember, 2 squared is 2 times 2, so that is 4. 2 plus 4 is 6, and 10 minus 6 is 4. Lots of 4s. So that is 4. Remember, you can always confirm in your calculator. All right, let's look at this one. All 3 variables this time. Y is 2. So we're just using these values over here that they gave us to plug it in for the variables in the expression. Sorry, x is 7. Got tongue-tied there. Z is 4, and y is 2. I don't love when we use the variable z that much because sometimes it can be misunderstood as a 2. Usually you'll see z's written like that with a line through it. So I'm not sure why this text do that. Sometimes they'll look like 2s, you know, sometimes people write their 2s like this and you can kind of get them confused. Be careful with that. All right, 2 over 2 is 1, and then we just have a bunch of addition here. So let's do that. I like to look for 10s. It's kind of a game. Oh, here's one. 4 plus 4 plus 2, that's 10. 8 plus 2 is 10. And then we can add 1 plus 7 and 10 and get 17. Kind of a shortcut there if you can find 10s. All right, so true or false. This is kind of similar to that multiple choice question we did earlier. We want to see, does the left-hand side equal the right-hand side? So let's just see if they do. 4 minus 3 is 1. 3 minus 4 is -1. Remember, we can do that KFC, keep, flip, change. So keep the first number, flip the second symbol, change the third. So the 4 is a bigger value in itself, so we subtract and keep the larger sign, -1. Nope, this is false. They're definitely not equal. Let's try number 2. This is a really good question. I got a few emails about this, and I think there's been some questions in your OMHS work. This little 2 here, this exponent, remember, it only affects what it's directly touching. So on the left-hand side here, it's directly touching just the 2. So this is going to be -2 times 2. Just the 2 is squared. On the right-hand side, the entire thing is in parentheses, and the exponent is touching the set of parentheses. So the entire thing is squared. So that's the big difference there, and it's kind of tricky. So let's see, -2 times 2 is -4, and then -2 times -2 is a +4. So this one is also false. And I want to show you guys this one in your calculator. So we could do -2 squared, and check it out. Desmos tells us it's -4. But if you square the whole thing, you can see you get a different answer. You get the +4. So again, that exponent only affects what it's directly touching. Okay, so now I want you guys to think of all the words you can think of that would represent these symbols. So when you see addition, what are some words that you think of? And you can write these in your notes. You can say them out loud. I know I'm not there to hear you. We think of some, maybe more than, of course, add, right? or in addition to. What about subtraction? Ooh, the difference of, less than. Multiplication, we think of mostly the word product. Division, you mostly think of quotient. There are other words, and we'll see that in a minute. The X I just wanted to point out is when you'll see the word variable. Sometimes it'll say some number. It'll be like the product of some number and 2. You're like, some number? Well, any number. So we use the X variable or Y. With equals, usually the tip off is the word is, right? Like 2 plus 3 is 5. So let me show you all the words I found. Here they are. You can definitely take a snip of this, add this to your notes. I'm sure most of this is review. This also included some parentheses words here. This word of helps a lot. Twice the sum of. So that's when those parentheses start. And of is another clue word for multiplication over here. So remember, with parentheses, that means multiplication, right? You have a parentheses next to a number, you know it automatically means to multiply. Ooh, another word here good for division I didn't think of was per. Subtraction, fewer than, less than. These are all good words because we're going to use these words to translate. We're going to be translators. So let's do that. Let's translate. So it's all translating is taking English words and turning them into math symbols, just like he did here. Here's the English words at the bottom, and we can translate them to this equation here on the top. So let's do that. For these examples, we're going to take the verbal expression and we're going to turn it into the algebraic expression. So remember, algebraic, of course, we're in algebra. That just means you're going to use numbers and letters. So the first one I want to talk about, it says less than. Anytime you see less than, you're going to take it off the back of the number. Here's an example. Joe is 2 years younger than Sue. Sue is 10. Sue is 10. So in your head, you would say, okay, Joe's 2 years younger, so 10 minus 2, right? Look, you took the 2 off the back of the number. You took it off the 10. You wouldn't say negative 2 plus 10, right? Even though the 2 comes first in this sentence, we're not going to write it first because that means something different when you're talking about subtraction. So whenever you see less than, it's going to come off the back of the number, minus 2. It says 2 less than a number, any number. So we'll use x. X minus 2. Let's try number 2. A number minus 2 equals 3. A number minus 2 equals 3. Number 3. 7 more than 2 times a number. 7 more than, whoops. So that's plus 2 times a number. As long as the 7 is, oops, as long as the 7 is positive, we know we're adding it. You could also write it like this. Totally fine, right? Because addition, they're both positive there. Number 4, 7 plus 2 times the number. That's another way to write it. Number 5, the square of a number plus 5. So the square of a number plus 5. 5 times a number is 30. 5 times a number is 30. So most of these, you can just write it as you read it. 16 divided by a number. There we go. Let's try going the other way. So we're going to go from algebraic to verbal. Now, there's going to be multiple ways you could do this because remember that slide that showed all those different words? That meant addition, subtraction. So what you see me put on the board is just going to be one way. You might think of another way. So here, look, the 9's coming off the back of that x. So we could say 9 less than a number. Right? You could also say a number minus x, or I'm sorry, a number minus 9. Here we could say a number plus 4 is 5. Or you could say the sum of a number and 4 is 5. Let's see. The product, so we're doing multiplication there, 3 times x. Product of a number and 3. I'm going to just say added to 7. That's one way you could say it. Let's try this. 5 less than the product of 2 and x. You could say the product of 2 and some number. I should have written out 3 and 2 and 5. Sorry about that. The last, or sorry, number 5, a number squared. So let's do the sum of a number squared and 1 is 8. This is kind of fun. There's multiple ways you could write this. And lastly, we have division, so we're going to use quotient. The quotient of, just going to write it like this. Again, there's multiple ways. 4 times a number and 2. Let's cross that out. 4 times a number and 2. So let's take it just a little bit further. Let's write the following as a numerical expression or equation. So this is where you're going to have a combination of things. And we're just going to kind of take it one step at a time. 1/2 the sum of a number and 4. See that? The sum of all of this is 3 less than, remember that's going to be minus 3 off the back of the number, the quotient of 5 and a number. So sometimes you just kind of work through it like a puzzle. I'm going to do this first. Quotient of 5 and a number. We know that's 5 over x, right? So let's kind of write that, help us. 1/2 the sum of this, a number and 4. A number and 4 is, so 3 less than this. 3 less than this. Remember, less than is going to come off the back. So it's going to come after the fraction, the minus 3. That's it. We'll leave it like that. You may have seen an example like this in one of your quizzes. All right, number 2, your bedroom wall has a length of 12 feet and a width of x feet. Write an expression to represent the area. So I'm very visual. Let's draw a picture. Here's our wall. It has a length of 12 and a width of x. What is the area? So I'm hoping you guys remember area of a rectangle. I'm guessing you do. If you don't, we do have a formula sheet for this class. You're welcome to use it the entire class. I'll post it in our page. Actually, it should be in there in our course. But area of a rectangle is just length times width. So our area is going to be, the length is 12 and the width is x. That's it. You could say feet squared. Remember, area is always squared. So you most likely would write it like this. 12 feet times x feet is our area. All right, example 3, we have a rectangular picture frame. Let's see if I can draw a picture for you. I'm not a terrible artist, but sometimes the pen is not very awesome. All right, here's the person in the picture. They're happy, I promise. Okay. It has a width of 9 and a length of x, 9 centimeters and x centimeters. Write an expression to represent the perimeter. So remember, perimeter means just the distance all the way around the outside of the shape. Right, so remember the perimeter is the distance all the way around a shape. So if this is x and this is x, if this is 9, this is 9. So all we have to do is add up all the edges. 9 plus 9 plus x plus x. We get 18 plus 2x will give us the perimeter. Now you might also remember the perimeter formula to be 2 times the length plus 2 times the width. It's just kind of like a shortcut way because we know in a rectangle there are 2 lengths and there are 2 widths, right? So you could do 2 times the length is x plus 2 times the length, or the width is 9. And we'll get the same answer, 2x plus 18. So it kind of just depends how you want to remember that. All right, example 4. So this is one that's very similar to what you've seen in your course. We got to work our way through it. There are 2 more horses than cows in a field. There are 16 total animals. How many horses? So we know C is the number of cows because it tells us that. And it says that there are a number of horses. The number of horses are 2 more than the cows. So number of horses are 2 more than the cows. How can we write 2 more than cows? We know cows is C, so 2 more than that would be 2 plus C. You could also write C plus 2. Now, how many total animals do we have? We have 16. So that's going to be C plus 2 plus C equals 16. All I did was I added up everything to give us the total. So that gives you 2C plus 2 equals 16. And that's it. There's our expression to represent this situation. Just wanted to show you guys a website that I've been working on. It's somewhat under construction. I am going to share the link with you guys in our online portal here. But let me show you. On this site, you can find a lot of information. So here along the left-hand side is the navigation. You can find a link to our middle school webpage, which hopefully you've seen, maybe your learning coach has seen. It has a ton of information just about the middle school in general. Here's a link to our calculators we're going to use, the scientific and the graphing. Here I'm going to be adding our class connect notes. So those are also in our online school. Let me show you. Remember, when you're in the algebra course, you just go to content. It's loading. And then along the left-hand side, you see guided notes for live class connect. So click that, and here they'll be listed by date. But I'm also going to put them here so we can sort of house them outside of the main lesson. This, I think, is going to be a page you're going to visit frequently, and it's going to be action review resources by unit. So we're in unit 1 right now, and this is the part that's mostly under construction. I'm adding resources. You can see these are all the resources that are here so far for unit 1. And I've listed them by topics. If you're like, oh, I need more help with fractions, here's a fraction review. Here's some help evaluating given a variable, translating, PEMDAS, expressions work. So anytime you're like, oh, I need more help, I need more practice, of course you can reach out to me. Also come to the site and check this page. Our connection corner is going to be back soon, but hopefully, if you saw, we are doing Friday free talk lunches, which was so fun last week. Keep an eye on your schedule for those. Here is where you'll see any extra credit opportunities. But don't worry, those will always be announced in class. I have a section on some real world math. A really cool, you can click on this video about geometry and about home construction. We'll start our newsletter soon. Our first issue will come out in October, so look forward to that. I hope you guys will be contributors of those. Once we get to practicing for our SOL, there's a lot of resources here for you guys. And we'll talk about these as we need them. Here is also that formula sheet. And then if for some reason you wanted to check out an 8th grade resources, I have those websites linked here. They have a ton of review resources. I wanted to make sure I showed you that. All right, you guys, I hope that you have a great day and I'll see you in class.